The broadcast is now starting. All attendees are in listen-only mode.
Good evening, ladies and gentlemen. Welcome to Sporty's webinar on glass panel flying. I'm your facilitator this evening, Eric Radke, President of Sporty's Academy, the educational arm of Sporty's Pilot Shop. Your presenter this evening on glass panel flying is David Zitt, Vice President of Flight Education at Sporty's Academy and also Flight School Manager, and one who certainly has a lot of experience in terms of glass panel flying. And we're going to be right back with David in just a second. A few housekeeping items. First and foremost, thank you very much for joining us. This, just to get, I think, a question on everyone's mind out of the way, first and foremost, we are recording this webinar presentation. So as we go along, if there is something that you missed or something you would like to hear again or see again, do keep in mind that we will have this entire presentation recorded and available at sportys.com/webinars. Again, the URL is sportys.com/webinars. That's the same page you went to sign up for this webinar. That's the same page you can always visit to sign up for future presentations. The recording will be there early next week. Throughout the presentation, if you have questions, which I'm sure you will, please feel free to submit those questions via the webinar software. And what we will do is we will pull some of those questions together, and we'll have some time set aside at the very end to ask those of our presenter, David. David, welcome. Thanks for being here this evening.
Well, thank you, Eric. I'm really glad to be here with everybody, and I'd like to echo your sentiments and thank everyone for joining this evening for this webinar on glass cockpit flying, which is, a continually evolving topic in general aviation.
David, if I can, let me start out with a question. That you've been one who has been involved in this technology, this evolving, emerging technology very early on. You've had experience with all kinds of different systems. I just read an article recently, a friend of mine, Jeff Van West, and he talked about the apprehension that is still out there by a large portion of the pilot community. There's just this kind of innate fear of these new digital systems that many of us didn't grow up with. Do you see? Well, A, do you see the same thing, and B, is it justified?
Well, sure, and with what we do on the Sporty's Academy, I definitely see that. Even now, still on an ongoing basis. Glass panels have been out now fairly prevalent in the GA industry for almost 10 years. And we still see that as being an issue, that some people still have that fear of transitioning and the difficulty they think they're going to experience by transitioning from, maybe they've been flying steam gauge, airplanes for 20, 30, 40 years, and some of the perceived difficulties they might have. But to answer your second part, which is, is that a real concern? And I would simply say no. With all the transitions that we've done, and myself included personally, I've never been able not to transition somebody if they've desired it. Learning computers and the computer skills that are required for using these glass panel systems are like anything else in aviation. It's just a learned trait. So I've not encountered a single person yet that has had to walk away from glass panel flying.
Understood. Well, David, I know you have a lot of material to cover, so I'm going to let you take it away.
Well, thanks, Eric. And once again, everyone, I'd like to thank you and welcome you for coming along. Flying with glass cockpits, as we were just discussing, has been prevalent now in GA for almost 10 years. So still an emerging technology as far as aviation concerns, and still something that a lot of people have yet to try, or if they have tried it, they've yet to move over full time. So a couple items on tonight's agenda. Let me just go through real briefly. We are going to start with how to transition from standard instruments, from the old steam gauge, on over to the primary flight display, the main display in the glass panel system. Then we'll talk a little bit about the MFD, or the multifunction display, and what it allows us in terms of navigational tools and some of the other features that it benefits us. Then we'll go into systems and system integration, and this often gets thrown around a lot in terms of buzzwords, a lot of industry speak, but I want to bring it down to what does this mean to you with what you're going to be doing with transitioning to glass cockpits. Then we'll talk about the instrument flying and approaches, which of course is very near and dear to most glass cockpit flying, and talk specifically about the do's and don'ts and some of the advantages that glass cockpits have over those traditional cockpit systems. emergencies, and some of those safety factors where I think most people get their apprehension about glass cockpits. We're going to talk about that stuff head on and try to point out a few things there, and then ultimately we'll wrap it up with some general takeaways about the advantages and disadvantages of flying with everyday glass cockpits, meaning stuff that we're going to do day in and day out. What I would like to start off with, though, is a quick survey, which is asking the people, the audience, as to which system do you currently fly with? Are you flying with the Garmin G1000? Are you flying with one of the Avidyne systems, either the Entegra, the R9s, one of the Aspen panel systems? If you're a experimental flyer, you're likely flying with one of the non-certified units, like a Dynan system, for example. Or if you're just new to the whole system and have yet to currently take on a glass cockpit full-time.
David, the poll's out there. I should have warned everyone this was coming. It looks like what we're seeing right now is just about half of our total audience is flying with a Garmin G1000 glass cockpit system, but the other half, or nearly half, about 40%, is not flying with glass currently.
Okay, well, that's kind of what we seem to expect nowadays. The Garmin G1000 system has been out for almost 9 years now. It has been 9 years. 2004 was when the first systems came out for Garmin. The Avidyne systems came out 2 years earlier in 2002. So a lot of times you'll find that Avidyne system out there if you're currently flying a second-generation Cirrus, third-generation Cirrus. A lot of the other Diamond systems back in the day, or nowadays, of course, the G1000 has been dominating the market. But hit it right on. For those of you who are transitioning, it sounds like for just about half of our audience members, a lot of times the most important question I get from people is, who can do it? Am I the right person to transition to glass? Is now a time for me? Is it better to be a low-time pilot or better to be a high-time pilot? And having done this now for, literally 10 years plus, transitioning and helping people get into the glass cockpit systems, I can definitively say that anyone can be the right person to transition over. Even if you're a casual flyer, you're not out there every day, that's okay. The glass cockpits can still be a benefit to you. One of the things you want to think about while asking yourself, how long will it take me to get comfortable? What do I need in order to transition? Is going to be obviously you, the pilot, the type of system that you're using, i.e. the Garmin G1000 system or the other type of panels, your previous experience, are you high time, low time? That does come into a certain factor. And then perhaps the most important piece is your instructor. Transitioning to a glass panel system is not something that you want to do by yourself by reading a manual. You want to find a qualified instructor that has experience in your type of system and experience in transitioning someone from steam gauges to glass. That person, that key piece of that instructor is what's going to make this whole transition fun and easy, or that lack of that person, or the inexperience in some cases, will turn this more into a tedious or frustrating activity, especially for some of you out in the audience that perhaps maybe do not have an overall love of computers. That's okay. You've probably experienced that. So we cover through that in the transition periods. I've been throwing out a couple names across the industry as to what's out there. I mentioned the Avidyne Entegra system. They were the first major glass cockpit system that was certified in general aviation aircraft, as I mentioned in the early 2000s, 2001, 2002, somewhere in that area. Really made prominent by Cirrus during their initial adoption. And then, of course, the Garmin G1000, which is arguably the most popular, especially OEM right now, and that does dominate the new aircraft market. Most OEMs are now covering with the Garmin G1000 or some derivation thereof, the Cirrus Perspective or the new G2000, G3000 systems. But that's not to leave out some of the other manufacturers that are out there, which are people like Aspen. Aspen has a tremendous following in the retrofit market, great system. I'll talk a little bit about them tonight. And then also there are many other manufacturers, some certified, some non-certified, that are out there. Dynan is a real popular one in the experimental category. Most of my presentation will focus on the Garmin G1000 system since that is the most prevalent, but we do talk a little bit about each of the other ones. Let's move it right along here and go into the primary flight display. This is the most important piece that you need to understand when you're transitioning from those steam gauges, because this is what's replacing your steam gauge instruments. This is where you need to go and look for your attitude indicator, your your altimeter, your airspeed, all of your primary 6. This is where you're going to go. So understanding how this panel works, but more importantly understanding what the instruments show you in this new representation is going to be the key to successfully making the transition. The rest of everything else are features, things that are nice to have, but the primary flight display is the stuff that we have to have. That's the absolute requirements there. The amount of information that you've experienced if you're not currently flying with glass cockpits but have sat in them at one point or another, or gotten a demonstration of them, which I imagine most people have at this point, can be overwhelming for some people. But you'll find that your standard 6-pack instruments are still here. They're still going to provide you with all those same basic pieces of information that you had previously, and in some cases really improve on some of the information that you were originally given, say from your altimeter, for example. So I'll move into a couple screenshots here. Much of tonight's presentation, I'll just take a couple quick screen grabs and try to point out a few little things that you guys can, everyone in the audience there can see what we're working on. This is a quick screenshot of a Garmin G1000 and a Cessna system. I believe this was in a Cessna 182, and this is just the primary flight display. So in here we're getting all of your primary 6-pack instruments. I'm going to go through each instrument here in just a moment, so don't get too concerned about taking each section of this primary flight display in at this moment. We'll get through each piece here in just a second. Some of the other ones that, like I mentioned out there, are the Aspen system and the original Avidyne Entegra. Now, I will also give a disclaimer for Avidyne. They've come out with some new systems since my photos. The ones I've chosen to show this evening are from their more prevalent Entegra system, the original systems used in Cirrus and several of the other early OEMs in the early 2000s. But that's what the primary flight display looks like on the left from the Avidyne system, and then the Aspen Avionics Evolution system there on your right is the primary flight display for a lot of the retrofits out there. So moving right on to each instrument here, let's take a quick snapshot of the Garmin G1000 for the altimeter. As you probably know, most of the instruments in the primary flight display are that of what's called a vertical tape style. So instead of having a round gauge, obviously, we're going to have a vertical tape which moves up and down and gives us a pure digital readout of our, whatever the gauge is. In this case, an altimeter I'm looking at. For the Garmin G1000 system, it shows you 300 feet above and 300 feet below on the vertical tape there, with a digital representation of the actual altitude you're at. I'll show you a couple other screenshots here momentarily, but that's the basics. It's going to give you that pure digital readout. Now, for those of you who are transitioning over for the first time, you will find this instrument, along with the other vertical tapes, to be a little difficult at first to understand. The reason being is much of us, especially if you're an IFR pilot, much of us look for needle position more than what the altimeter airspeed indicator actually says. You're used to the altimeter, say, being at the 12 o'clock position. Well, unfortunately, we don't have a 12 o'clock position in the digital altimeter. All we have is a pure numeric representation. As such, sometimes it takes people a little bit longer to get used to reading that number and then processing that information. One of the things I mentioned early on about the possibility that your instruments may be able to provide you with more information than you're used to is the fact that a lot of the vertical tapes have what are called trend indicators. And you'll notice on your screen right smack in the center, I'll bring my mouse over top of it, you can see it here as this red dot in the center of your display. There is a purple line that is developed out of 3,100 feet now, pointed downward towards the 3,000 marker. This is called a trend indicator. This is telling us where we're going to be in 6 seconds in the future. So kind of a nice little genie to be able to tell us what's going to be happening here in the near future. These trend indicators are very useful in trying to accomplish smooth level-offs, instantaneous analysis of an unusual attitude position, things like this. Your transition instructor will spend a lot of time with this. Airspeed indicator on the other side here, kind of the same idea. We've got that trend indicator on the right-hand side, a numeric representation, and of course all of your standard color displays. All your green arcs, your white arcs, yellow arc, red line, things like that. But in addition to those features, you also have some enunciated particular speeds like V speeds, VY, VX, VR. Each of your OEMs or the actual aircraft manufacturer specifies which V speeds get bugged, and all of them are pilot changeable. You can sit there and manipulate those speeds if, once again, you calculate something different for VY or prefer to use something different for VY in your aircraft. But that's what the airspeed indicator looks like. If we bring our attention over to the center of the attitude indicator there, this is probably the largest, what I would call pure improvement over the traditional six-pack instrument, in that the attitude indicator really takes up the entire display. You have a horizon indicator that goes from the far left to the far right of that display, and the blue sky all the way to the top and the brown earth all the way up. So instead of dealing with a much smaller round gauge right in front of you where it's very difficult to see the individual markings, you actually have a much larger display. And your attitude indicator, as a result, tends to be a trite bit more accurate because you can see smaller deviations. For example, you can see a 2.5 degree pitch up change, whereas most attitude indicators in most aircraft, you'd be lucky to see a 5 degree differentiation. But that's it. The scale at the top of the screen, of course, is your bank indicators. Here's your 10 degree marking, for example. I'll put my marker over that. You can see the 10 degree, and then 20, 30, 45, and 60. Are the appropriate markings as we move along. The HSI down below, if you haven't flown with an HSI previously, once again getting instruction on an HSI is probably useful beyond just simply the directional gyro that you might be used to flying with. But the HSI that you have here in these glass cockpits are no different than a mechanical HSI in most of their features. So if you've used an HSI previously, these HSI really shouldn't be much different for you. A lot of information to be displayed depending on the manufacturer. Most of these HSIs also have RMIs displayed. In this particular graphic, I have two VOR RMIs being displayed in the background for both NAV1 and NAV2. But we'll talk a little bit about that later as well. So that concludes kind of a brief review of the primary flight display. Like I said, I just want to talk a little bit about transitioning initially. Now I want to move into the multifunction display, because the MFD is where you're going to see most of the dramatic changes and features that you hear about in glass cockpit flying. The MFD is, depending on your options from your manufacturer, your gateway into navigation, airport information, database facts, in-flight weather, systems status, checklists, approach charts, you name it, all going to be located somewhere on that multifunction display. And as I tell people, that MFD is where you're going to get that big wow factor. That's where everyone gets to go, wow, this thing does this. This is amazing. As we move into the MFD's primary function, for most of our flying experience is going to be the enroute navigation section. This is where you're going to get a lot of that benefit coming in. The multifunction display, as glass cockpits are by their very nature, a hub of information for us. It's a singular access point to get into GPS navigation, our flight plan information, in-flight weather, once again, instrument approaches, database, airport information, nearest airport, blah, 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 blah. The list goes on and on and on. But that's where we're going to get access to all that information. What I describe to most of my students when talking about what does the MFD do for us as far as navigation goes, the answer is easier planning, easier inputting, and easier flying. We use this as our central nexus, as it were, for most of our flight operations. I'll run through a few screenshots here for what some of these multifunction displays have to offer. The first display picture here is of that of the Avidyne Entegra. You can see, once again, given the age of when these came out, are a little bit more simplistic in terms of the map overlay, but still a fantastic situational awareness tool. And on the original Avidyne displays, you can see that they use what we call data blocks. In the top left-hand and top right-hand corners are where they display most of their information. That screenshot comes from this cockpit photo here of the Cirrus SR-22. This was a Gen 2, I believe I was flying at the time. So this gives you an idea of representation of where you might see this. The Avidyne system is an element of notation back in this era were dependent upon outside navigators, i.e. the Garmin GNS 430s that you see there in the display. They were the ones driving the information for those displays. Some of the navigational tips, though, once you've tuned in, you've talked about what can the system do for me that I'm not already getting. And that is, number one, for those of you who are using the Glass Cockpit systems, particularly G1000, make sure that you're using your flight plan page and not just inputting direct a destination. And the reason being is the sequence and information that the Garmin G1000, as well as the other units, get by using your flight plan allows the system to understand more of the targeted goals. What are you trying to get out of your flight today? And furthermore, by using that flight plan, you're going to get access to information like flight calculations and fuel planning information, in-flight weather, a lot of things that are not automatically displayed if you are typing in destinations by the direct-to window only. Using that flight plan gives you access to that stuff more automatically. As another note, I always tell my students, make sure and enter your departure procedures and stars. If you're an instrument pilot and you're doing DPs or stars in or out of your airports, make sure and enter those into your flight plans to help reduce some of that pilot workload and have that navigator helping you out a little bit more. Excuse me. One of the more recent features, it was always in there, and these features are even in there for those of you, say, have a Garmin 430, for example, in your panel right now. You already have a vertical nav planning system. The Glass Cockpit systems take that vertical navigation to another level, and I tell my students, always, always use your functions of the vertical nav planning. That translates to engine management. That translates to, all different other facets of, what I call, finalized flying to be able to make that a little smoother process. So use that VNAV planning to make sure that you're doing smooth and casual descents coming out of those higher altitudes if you're doing IFR flying. The cross-check and the trip planning page with your pre-flight planning. One of the great things by piping in all of your flight plan information is that the system makes a lot of up-to-the-moment calculations. Most of these systems have fuel flow transducers and fairly accurate fuel gauges, and you can cross-compare what you have in your original flight plan and cross-compare that to what are the winds of the day doing to you. How is that going to affect our destination planning? Do I have to make an altitude change to still get there, or am I going to need to put in for a fuel stop? Do I need to let ATC know that I've changed, slowed down? Whatever the case may be, but that information is readily available at your fingertips. And one of the things that I kind of always try to impart upon everyone, and I hope that you take this one away if you're currently flying with your system, don't just leave your MFD sitting on the map page. Most of the time I fly with people, that map page is always up there. And don't get me wrong, it's probably the single best resource for situational awareness. But your system has so much more information to provide you. I tend to find myself kind of almost flipping the pages on an ongoing basis. Here's just a quick screenshot of the Garmin system, what it looks like in the Garmin G1000 as far as a map. If you compare that back to that Avidyne picture that we first saw, you can see that this map is a little more active in terms of the amount of terrain features and airports and airspace features, that kind of thing, county roads, a little more detailed. Once again, a little more attribute to the newness of the system. I referenced earlier to the importance of using your flight plan. Now, each system of the G1000, if you're out there, you'll notice that this flight plan screen might look a little different than your aircraft. Each OEM configures the G1000 slightly differently, but this is what it looked like in a Cessna 182 at the time which I took the picture. Just gives you all of your waypoint information on the right-hand side, and in this case I also had an instrument approach loaded up coming back into Claremont County. There at the Sporty's pilot shop, and then all the leg information and all the different desired tracks for each of the legs. You also see, if you scroll down kind of north to the bottom of your screen, I'm bringing my pointer over there, there is an active leg information that gave an enroute safe altitude of 3,200 feet. So some of these features, once again, about that vertical nav planning, kind of helps in a moment's glance know about IFR or VFR safety. One of the things that I think almost every pilot I know that uses these systems absolutely loves is the database information that is readily available at your fingertips. You flip the page knob right there, and instantaneously you have access to airport elevations, length of runways, frequencies, center changes, you name it. The information is at your fingertips, different types of approaches. And inside of each of those, you have the ability to access the frequency and have the system what's called auto load, or literally digitally tune the radio for you. So if you wanted to switch on over to the Unicom there displayed of 123.05, you literally highlight it and hit the enter key, and it punches it in the radio for you. No more tuning one number instead of the other number, which I know if you're like me, it's happened countless times. Downlink weather. Moving on from a little bit of the MFD features for a moment, downlink weather is probably the single best add-on that you can get to these glass panel systems. Now pretty much considered default standard. At the time they used to be optional. The way that in-flight weather has changed general aviation in the last 8-10 years has been almost remarkable. If you haven't used it yet, I highly encourage you to get an opportunity to try it. It will probably revolutionize your flying, and just what you can get inside these cockpits really is startling. I have a brother-in-law that's an airline captain, and I kind of joke with him that when I fly in the 182, I've got more technology on board than he has in his 737-800. And that's just the rate at which things have been changing. It's quite amazing. But downlink weather is fantastic for planning and avoidance and understanding the weather situation as a whole, and ultimately for helping pilots like us making decisions on the fly, as we know that the flight environment is always changing. Downlink weather, on the other hand, is bad for radar penetration. These systems are not designed for storm penetration. The time delay, which I'll talk about here in just a moment, is downright almost dangerous in some cases. So you really have to be careful about using it for just general avoidance, not penetration. And then, of course, that what I call the overinflated self-confidence factor, whereby now suddenly, I've got the ability to see radar on board, and you start to become emboldened with your cross-country planning, whereas before you probably would have simply sat it out on the ground. You have to be careful about those kind of situations. And then what I refer to as automatic decision-making, meaning, well, I've got weather on board, surely I can handle it. I think most people out there don't have that mentality, but that is ones that I have come across. Here's a screenshot of a Garmin G1000 in flight looking at XM NexRad. This is a composite radar image. This is just a local flight here out of the Cincinnati area and dealing with a fairly large weather system. Fantastic for the big picture. We were making a short hop to a county airport nearby, had a nice break in between the weather has moved off, and our destination was fairly clear. Now, just as an example, I include this picture here, which is now showing up on your screen, of a hurricane coming in off the Florida coast. Obviously, this system shows you pretty well that there's a big, nasty ball of weather out there. What the system, of course, doesn't do is give you all the other stuff that comes with that knowledge. So you do still have to interpolate between the picture and what you know the weather phenomena to be out there. This is a snapshot of the Avidyne system looking at airmets and sigmets, which is another fantastic feature to have in flight, the ability to see changing airmet conditions. Obviously, we can see this flight that was heading out west to Albuquerque just riddled with every type of airmet you can get out that way. Great for that general big picture kind of stuff. Once again, not for the finite stuff, but the big picture, absolutely fabulous. I do take a screenshot of this. This is an actual screenshot of a storm base that down south. And the reason why I take a pause on this one is this is a screenshot of the exact same weather condition day where someone using a similar system, it wasn't in a G1000, was trying to penetrate that particular line just on the western edge of the MOA, and believed that they had enough information to determine the weak spot in that flight line, and decided to go ahead and give it a try. ATC, of course, and discouraged them, but nonetheless they had the information, and the choice is always up to us. And unfortunately, got themselves in a changing weather condition pattern that happened so quickly, did end up in 2 fatalities. That's a common occurrence you've probably seen. There's several articles out there talking about the weather delay inherent to data link weather. Just remember that the image you're seeing, and there is a time display on these images, but make sure that you understand that that time display is not the time that the radar came in. That's the time that the image was transmitted to you. That doesn't necessarily say how old the image is. So some of the stuff you could be looking at out there could potentially be 10, even 15 minutes old. Great for general avoidance, bad for penetration. Speaking of in-flight weather, a lot of you, I'm sure, have been reading and hearing about ADS-B. This is not an ADS-B seminar. I will not spend a lot of time talking on ADS-B, but I just want to point out that they're absolutely been revolutionizing in-flight weather and bringing subscription-free weather for most of the country coming in just droves by most people. Really big right now in the portable markets. All sorts of different products out there. But so far, the certified panel manufacturers, i.e. Garmin, Aspen, a few of the other ones, have been fairly slow to get integration solutions into their existing systems. Now, that disclaimer being said, they have finally come out with these systems and are currently in the process. Aspen's been pretty quick with their ARX series. You can buy these boxes. Not much to look at, obviously. It's a panel mount system behind the screen, and that's going to give you some of this subscription-free ADS-B weather displayed on your primary or multifunction displays. The Garmin systems now have the GDL88 series, but you'll notice several asterisks there. For those of you currently owning a G1000 or flying G1000, if you've been in talks with Garmin, you'll know that the GDL88 series does not yet support the G1000. I talk to Garmin fairly routinely. Of course, that's always one of my pressing questions, is the G1000 is close to my heart. And they simply say that, it might be in the future. So stuff to look for. Currently, the GDL88 series gets you that ADS-B weather on GPS navigators like the GTN 750 series touchscreens. Over to engine management, which is another topic which I think is really beneficial in the Glass Cockpit systems, because almost all of the MFDs out there have some form of engine monitoring system to replace standard mechanical engine gauges. And what we've got in this engine monitoring is nothing short of amazing. Graphical engine monitors, the good old simple monochrome red GEMs, were revolutionary and really quite sought after by most of us. Now the technology we've got in these glass panel systems trumps those graphic engine monitors and really kind of puts them back in the past, so to speak. With all the accurate improvements and everything we have, it just makes engine management that much more precise, and hopefully the ability to get a lot more hours and years out of your engine use. Each of your computers, most of the system on the market, assuming that the OEM has approved your engine for both best power as well as best endurance or lean of peak operations. So it literally walks you through that process step by step, assuming, of course, that the OEM has approved it that way. Here's a little snapshot of the Avidyne engine page for the Cirrus. A really nice display. They do some graphical representations of round gauges at the top there that show you RPM and manifold pressure. And then, of course, you get the more graphical bar displays of the exhaust gas temperature and cylinder head temperatures, fuel display, engine displays. A lot of really nice information. That engine leaning page I was referencing to is popping up right now for you. And this is just a great display saying, hey, your hottest cylinder has peaked. And then from here, you would continue to lean for lean of peak, or you would re-enrich, and of course, for best power solutions. The G1000 system, depending on your OEM, this is what it looks like in a Cessna, has a similar function, same idea. It's going to detect that peak, a little bit more traditional as far as the old graphic engine monitors of the past, and give you simple temperature displays, and then gives you the graphical representation there, also the cylinder head temperatures below. On into navigation, kind of coming back, so what's new? We've all had GPS, hopefully, and if you haven't had a GPS, what GPS can do for you is nothing short of amazing. So what's new that these systems are bringing into play? The WASP, V, and LP approaches are pretty much out there. G1000 systems have retrofits if yours is older or from the newer series. Once again, the Aspens are being driven by your individual navigator. So once again, if you've got a WASP GPS approach, that's going to be brought right in there. That coupled VNAV planning or vertical navigation planning now, depending on which system's out there, can be so advanced that you can do climb profiles and descent profiles with autopilot integration that pretty much allows you to fly hands-off all the way from after the climb out phase all the way down into the final descent planning. It's quite amazing. TAWS-B integration, you no longer need individual boxes or a specific MFD to bring in that terrain warning system. And as I referenced, ADS-B, both traffic and weather, now being adopted by most of those manufacturers out there, and if not, seems to be on the horizon in the near future. A lot of the features that most people really kind of looked for a long time, especially if you were an early glass panel adopter like myself, you're really looking out there for that 3D terrain mapping, that little visual display in the background of what's out there, and then synthetic vision, which is also in conjunction with that 3D terrain mapping, including the well-toted highway in the sky system, whereby you literally fly through the boxes in the sky virtually. That stuff is out there. The navigation potential is amazing. Some of that's on primary flight displays. Some of that's on the multi-function display side. So this is just a few screenshots of some of that technology out there. This was the TAWS system that was represented in the Cirrus, in the Avidyne system. Once again, a little older, but an amazing system as far as terrain avoidance. And then this is was Garmin's initial response. Was Garmin Terrain Awareness. This feature was available on every G1000 system, and then they also have a version of this panel system of color coding that's actually TAWS integrated. I mentioned just a moment ago that synthetic vision, and this is the stuff that really just kind of blows most people's hair back, so to speak, and that this 3D terrain map, you see that top left-hand corner there where the mountains are being color-coded yellow and red to indicate their altitude to you. The obstacle that's on the right-hand side, and then down in the picture below is the virtual highway in the sky, those purple boxes that are out there. What you can see in the visual representation of situational awareness is truly unprecedented for general aviation. Talking for just a brief moment about the G1000 system itself, a lot of times people like to know about what makes the G1000 go. So I'll talk just for a moment here about what components make up the G1000. Please keep in mind that each G1000 system is different. Each OEM does a slightly different integration. But G1000s consist of individual components called line replaceable units. Each LRU talks together kind of like on a computer network kind of idea, and Garmin's system is designed to be a little bit more user serviceable, whereby if there was a problem with a box, something went bad, you could take out that box, pop it out, get a replacement unit, pop it back in, thus lowering some of your maintenance costs. A lot of that also individual components is a lot of what they talk about their redundancy built in, and of course the reversionary mode, which almost all the display panel manufacturers now have, which allows for primary flight display information, i.e. your attitude indicator, to be displayed on your multifunction display. An essential piece, obviously, if you're reliant upon a computer system. Here's a quick little diagram of the Cessna 182 implementation of the Garmin G1000. Each one of these boxes that you see on the screen is an individual component of the system. All the lines that are connecting everything are communication lines. So you'll see that there are a lot of boxes of the G1000. Some of these are in the panel. Some of these are in the tail cone, in the example 182. Some of them are also located up front in some of the twins. Nowadays, most of the G1000 systems out there have additional redundancy beyond what this display is. This display is just a little bit older, whereby it only had one attitude heading reference system, an AHAR system, or essentially an attitude indicator for steam gauge parlance. Nowadays, they have redundancy on those, whereby if one fails, you still have an attitude indicator system. Now, that system design is in comparison to a little bit more of the simplicity of the all-in-one systems, things like what the Aspen primary flight display shows. You can see that image on the left-hand side, where they have all of their necessary components in one singular item that is literally drop-in replaceable for your attitude indicator and directional gyro that you might have in your steam gauge aircraft currently. The Avidyne Entegra, that's a picture of their R9. That's their newer implementation. That's once again an all-in-one box solution. You can see it's a little bit deeper there. That just pops right in the panel in replacement of the other ones and is an all-in-one solution. So we talk a lot about integration with glass cockpit systems, and unfortunately, aviation is one of those industries, as we've all been living with for years, that we like to throw out a lot of terms, and sometimes those terms don't always have a lot of meaning. But what is integration, and what does that have to do with us as pilots? And the answer is pretty simple: is that it allows us to do a lot of tasks, a lot of different things, with less work and confusion on our side. Rather than as if you had to do the same task with multiple devices. So the idea with integration is you can do one-stop shopping. One singular box, one singular entry will translate to both your GPS, also translates to your, your autopilot in some cases, or right on over to transponder information, you name it. So here are a couple of examples that I have for what does integration mean to us as pilots. The first one, of course, is the ability to enter vertical speed to coordinate our VNAV planning descent from altitude. If we're coming out of, say, 10,000 feet, trying to descend down to 1,500 feet, and we want to be at a specific point to the airport so we can enter the traffic pattern properly, we can type all that into the one box, and then the autopilot will pick that up, and then the autopilot will begin the descent based on the information I put in there. That example, of course, is in a G1000 system with the GFC 700 autopilot. But that's just one idea. The other one would be databases, one singular database that would hold all of your airport information, your approach charts, your altitude requirements, terrain information, in-flight weather information. All this is available at a singular location, which just means that you're able to grab information much, much faster than out the green airport and facility directory, or try to look for that on the sectional chart. It just makes all that information easy to get at your fingertips. And then, of course, nobody can deny the safety that comes from, I like GPS, but GPS still needs to be checked. Well, when you have these kind of systems, there are almost always at least two GPSs acting as one, always cross-checking and verifying their positional information. So the two of them are talking and comparing and making sure that what they're believing you to be at is in fact accurate. I mentioned for a brief second there autopilots. I kind of gave a brief flash. I'm not going to spend a lot of time in tonight's presentation about autopilots. There have been a lot of advances in autopilots, but autopilots haven't been advanced per se as a result of glass panels themselves. Now, there have been a lot of improvements to autopilots over the years, particularly GPSS. If you're not familiar, that GPS steering assist, which allows your autopilot to hunt a lot less back and forth across the course. If you're familiar with a slightly older autopilot, you're trying to track a navigational signal, it tends to want to wander one side back to the other. It gets you where you're going, but it tends to be a little bit more nerve-wracking. The newer autopilots, like the Garmin GFC 700 or the Avidyne DFC 90, which hit a lot of press, really big because they're attitude-based autopilots as opposed to rate-based autopilots. It allows for a lot of accurate information there that really is improving the quality of the autopilot's functionality. Not to mention, of course, with the increase in computer technology that's driving that. With that, I want to take just a brief break here and bring in an instrument flying survey. If Eric can help us out a little bit here, the polling is open for bringing in whether or not you currently fly IFR with the glass cockpit more than 50% of your flights, or if you get an opportunity to try it a little bit less, or ultimately, if unfortunately at this point you still have yet to try that glass cockpit flying or are not in the instrument system.
Dave, the polls in the field and the results are showing it looks like it's kind of a split. For the ones that are flying IFR, it looks like about half and half in terms of more than 50 versus less, and then of course, and then upwards of close to 60% are not.
Okay, well that's between the combinations from our first survey about not flying with glass cockpits on time of that for IFR flying, not unexpected at all. That's kind of what we tend to see out there in the industry when we're talking to most pilots that are interested in glass cockpit flying. I will talk a little bit about instrument flying in here, and these are just general to-dos and general advice I always recommend, as any good CFI would, to find a local flight instructor and that expert flight instructor have you work with those instrument approaches, because instrument approaches in the glass panel system is a little different than if you were flying with the steam gauges. The great thing about flying instruments in the glass panel system, that's where glass cockpits really shine. Glass cockpits are great for VFR flying. I use it for that all the time myself, but it doesn't get much better than the instrument flying environment, because the amount of information that it pulls together just makes instrument flying so much easier. Situational awareness and approach setups are dramatically improved over some of the more traditional older GPS systems, or in the event that you weren't previously using a GPS, the ability to load up an approach and have the system automatically load up the localizer frequency for you and tune it in and identify it. You don't even have to do that anymore. That can be done for you. All of your departure procedures and arrival procedures are all laid out directly in front of you in step-by-step procedures graphically. Makes for that whole process and knowing which step you're in a lot easier. And as I already mentioned, those frequency systems, just absolutely what a pilot reliever in terms of having to tune your own radios. Here are a few screenshots here about the different systems. This is the Avidyne RNAV approach for GPS runway 19 into this airport. Here is what it looks like on the multifunction display. And if you burn that into your mind for just a moment, we're going to flip on over into what does that same approach look like on the primary flight display for this Avidyne Entegra. And you can see that they have a miniature map right underneath the HSI right there, in addition to your normal HSI features. So it's kind of cross-tying that information there, so that at a glance, when you're navigating, you can see where you are and keep that situational awareness, as high as it possibly can be. The Avidyne ILS, this is a screenshot I have of what it looked like in the Entegra system doing an ILS. They brought all the information you needed from your navigational instruments right on top of your attitude indicator there. Directly below the bottom of the attitude indicator, I'll bring my cursor on over, is your localizer deflection. And then directly to your right-hand side, right next to your altimeter, is your glide slope deflection. Now, for most people who haven't flown glass cockpits, moving these instruments away from the HSI is sometimes a learning curve. But once you get used to it, when you're trying to fly down to those minimums, looking at decision altitude, it couldn't get any easier when you're following the glide slope and the altimeters immediately right next to it. It brings in that instrument scan so much tighter. Over to a G1000 display, kind of in comparison, this is what the multifunction display looks like for an ILS approach. Pretty straightforward, just showing a localizer and the extended center line from the multifunction display. And then the exact same display now from the primary flight display side. And you can see that the G1000 HSI is a little bit cleaner representation. Now the Avidyne system, I will mention, of course, you can turn on and off those map features, so you can make it as clean or as cluttered as you'd like to make it. But the G1000 system at its heart is a little bit cleaner as far as the HSI is represented. When you're going on in the instrument world, as far as glass cockpit flying, there is some good do's and don'ts that you want to make sure that you're using when out there flying. The first one is probably the most obvious, but there are some of us out there that do want to try to save a buck. But that is, you've got to make sure that your database features are updated so that they have the most current information. Not only is that required by regulation, but that's just a convenience factor, making sure that we've got the correct frequencies, all the correct altitudes for the latest approach, and all the information is available at our fingertips that's going to be useful for us. Now, the other disclaimer as a don't is that don't use that information by itself in lieu of a full approach briefing. Sometimes we get so lured into the fact that the system does almost everything for us in some regards that we tend to rely a little bit less on the approach plate itself, and that's something that can be very dangerous. You want to make sure and still use your standard approach briefings and procedures. Using those approach maps to aid in situational awareness is an absolute must. The MFD can provide more situational awareness in an instant looking at it than 10 or 15 seconds of staring at VOR indicator heads. And that's pretty universal. If even you've never tried it before, you will find the situational awareness to be an instantaneous pickup. That's not a real challenge for most students. The one that I do mention, though, of course, is never to allow the capabilities of your system to dictate your minimums. We talk a lot about personal minimums. If you haven't heard the term, the FAA has a lot of information out about the idea of personal minimums. But never let the capabilities of the system dictate to you. Just because the system can take it down to 200.5 and a full autopilot couple doesn't necessarily mean that your instrument proficiency dictates a 200.5 approach. Here's a real quick screenshot of the digital charts of the Jeppesen view on the Avidyne MFD. Now almost all the major display manufacturers have charting options whereby you can get legal charts on your multifunction displays. Jeppesen obviously is out there, as well as the governmental charts are out there now in most of the systems as well. Some of the advantages over the traditional panel layout in that context there would be improved situational awareness, as we've already mentioned. That's an obvious. The ability to brief and prepare your approaches faster because they are being displayed on that MFD right next to you, keeps your instrument scan up, being right next to the PFD, and it's right available to you right at your fingertips. You can change instrument approaches if you have to. If you go miss somewhere, you need to reload another one. You don't have to go sorting through a book to find it. It's just a finger touch away. And with those same charts also come all the information that's on there now in a digital way. The current weather information, the frequencies needed, the different approach options as far as the approach procedures, all that's available just at the snap of a finger. When we are flying instruments, there's a lot of instrument safety that we need to take into account, and that's where I think a lot of people, when they transition over to Glass Cockpits, really spend a lot of time with me and try to talk about, Dave, how is this going to affect instrument safety? Because I want this, this Glass Cockpit system to improve my safety, and how is it going to do that? Well, the first one I always mention is that you've got a computer system kind of checking you the whole time. Rather than us being the only ones checking the instruments, now us checking the instruments along with the computer checking the instruments adds another level of protection. And all these systems have some form of red X's to indicate individual failures. Rather than following an attitude indicator into a graveyard spiral, for example, we're going to see a big old X that just pops up and says, you know what, you can't use that. Of course, we have backup gauges in addition to the Glass Cockpits themselves, and all the system malfunctions that the system's looking for far exceed, other than just a traditional vacuum failure. Terrain avoidance assistance, when you have that system built in, is automatic. It's not something that you have to do, so that's adding another level of protection without doing any real work on your side. But the only downside to all these safety features is the over-reliance factor of sitting there and enjoying thinking the machine's going to take care of itself all the time. Here's a quick snapshot of a G1000 when you've lost your attitude heading reference system. The moment you lose that, you see an awful lot of black on that display. That's not a good picture, obviously, but it is a definitive picture. I don't think anybody looking at that screen right now has any question about whether or not your attitude indicator is working. So as a result, we can immediately switch over to the backup systems, which is very convenient. Not going to get that graveyard spiral. Emergencies are not as prevalent per se in the Glass Cockpit systems, but we do have some improvements and some detractors there. The big advantage, of course, with the glass panel system is information. If we had a system malfunction not related to the glass, we are going to be able to access a lot of information to be able to help us out, like checklists or computer analysis of the problem. It's going to help things go faster. With the addition of glass panels, though, we have added some emergencies that are now unique to the computer system, i.e. screen failures, computer component failures, things of that nature. Those things are now things that we have to train for. But thankfully, because of the systems, they're normally fairly self-evident and fairly clear as to how we need to handle them. In the event that we do need to handle an emergency, the glass panels can provide an immense amount of information that's useful, that can help us make a snapshot decision about a close airport, or which airport's the better one to land to, or which way the wind's coming from. All these things can be very useful. but it's how we use that information that ultimately becomes the deciding factor of whether or not glass panels are safer for us, whether instrument or VFR. That's how we use that information is ultimately what the benefit's going to be. The only downside, especially for the early transition, is going to be the information overload factor. You know, in the event of an emergency, am I still flying the aircraft first and foremost? Your instructor probably always told you, fly the airplane, aviate, navigate, communicate. So you got to make sure the information doesn't take your attention away from other important factors. Here's just a quick snapshot of the SR20, Cirrus SR20 and their emergency procedures. So when you need an emergency checklist, it's right on the display, literally a button push away. Here are a couple of situations that have been traditionally vexing in standard cockpit, steam cockpit situations. You know, what happens when we get spatially disoriented, get into an unusual attitude? Well, the great thing about the primary flight displays, they have a lot of things to help us. You can see the two trend arrows. I'll put my pointer here over the airspeed indicator indicating the airspeed is climbing, and the pointer over here to indicate that the altimeter is descending. We can obviously see our attitude is approximately 25 degrees nose pitch down. The chevrons, the white chevron pointers here, pointing us back to level. It's very crisp, very clear as to what do we need to do to correct. G1000 has an almost similar feature. You can see right there the red chevrons, they use slightly different colors, and the G1000 also declutters its display when you do get into that situation. It takes away several boxes to bring your attention to the important features. Some of the other possibilities of failures, of course, would be a communication system failure. What if we lost, in the case of the G1000, if we lost one of the units? We simply get red X's. Once again, if we lose a comm system, we don't have to guess whether or not the radio is functional or not. The system checks it and physically indicates that they're not. Here's a close-up of what that looks like if you're straining to see the picture up close there. Literally just gets a big red X right over top of the instrument panel display there. In the case that we would have to encounter a multiple failure situation, here's a picture of what it looks like when we've lost an AHRS, we've lost a communications radio, and we've lost our altimeter. Once again, a lot of black space here, a lot of red X's, a little concerning, but each one is very, distinct. It's not a whole lot of question as to what the issue is. One of the great advantages, of course, of the Glass Cockpit system is that we have, essentially unparalleled redundancy built in, especially the newer systems now. They continue to come out with additional backup systems that are already built into the panels. We have secondary electrical systems in every aircraft that's certified. You do have backup mechanical steam gauge instruments that are in every aircraft that has these glass panel systems, and of course the ability to display your primary flight display on other displays. So the amount of information you can get from these in an emergency situation is amazingly helpful. The big advantages of flying with glass, this is another one people want to ask me a lot about. What are the reasons? Why should I retrofit? Why should I buy a new aircraft? Well, the first point, of course, is navigation integration. What you can do by punching in one destination into your flight plan and the amount of information it gives you is amazing. I mean, if you haven't flown it yet, like I said, get it a chance to try. Find an FBO, do a rental flight, find a friend, go out and do a demonstration flight. It's amazing what you can get. The large instruments, I cannot describe how improved situational awareness you have when your attitude indicator is no longer a small round gauge in front of you. It's now a large, full 10-inch display. It's clearly, an ability to snapshot, see what your attitude information is almost priceless. The amount of information, of course, that you're getting through these things, the safety and backups I've talked about extensively so far. And then the other one, which I haven't really mentioned so much, is the cost-effective advanced systems. And I say cost-effective. Please understand that everything in aviation costs money, and we all know that, we're pilots. But the availability of adding in-flight weather or a TAWS system or a traffic information system, for example, the costs for these systems are much smaller in comparison to if you had to get a dedicated standalone unit. The integration in these glass panels offer that increase at a much smaller price point. Of course, there are some disadvantages to having a glass panel, and some of those are essentially the people factor. It's not much of a technology issue. It's one of them being the over-reliance on the advanced technology. We become very complacent very quickly, and then we no longer train ourselves in the backup instruments. As a result, people often claim, well, if I fly with glass, then I'm navigationally ignorant. I no longer know how to use a chart. Each pilot's different. I don't believe that the system is going to condemn you to navigational ignorance, but being committed to staying up on your old skills is still very important. The lowering of personal pilot minimums. Some people fall subject to the idea that once again the computer can do it, so I'll just let it do it. If you did have to transition back into a standard steam gauge aircraft, your instrument scan will be different as a result of having flown glass cockpit on a full-time basis. As a result, you do have a little bit of a degradation of that standard six-pack instrument skills. Like I said, some of that macho attitude of now the system's got so many features I can get into pretty much anything, and some people have that overall false sense of security. But like I said, all these disadvantages on the display are generally on the pilot side, so not a whole lot to worry about there as long as you're diligent. So wrapping things up this evening, glass panels have obviously brought an amazing amount of information and revolution over to general aviation in only the past few years. And I say few years, I mean keep in mind how long general aviation's been around and how much change we've experienced. The amount of technology that we're getting in the cockpits now in the past 10 years alone is more impressive than what we've experienced in decades previously, especially at the rate of change that things continue to go. And that information and technology improvement obviously continues to offer information and safety features to general aviation that we didn't used to have access to. Hence my joke I made about my brother-in-law flying that Boeing 737. The information that we have and how quickly we can adapt is just impressive. And those tools can be used to better our safety record in general aviation, I think, on any day of the week. So with that, I'd like to, thank you all for attending tonight's webinar, and I will turn the floor back over to Eric and see what questions might be out there that I can be able to help out.
Thanks, Dave. Great presentation, a lot of information, given everyone, I think, a lot to think about. One theme that has come up several times this evening is some discussion or thoughts on reliability. This is not probably an easy question for you to answer, but let me just kind of use this as a starting point. Are the glass systems reliable? And if that's a yes, can you kind of compare that to the old-fashioned round gauge instrumentation?
Well, sure. I mean, it would be easy for me to immediately say, well, yes, of course they're reliable. I'm not an avionics technician. I can just say from my, thousands of hours of flying in glass cockpits that, the instances of failures that I've experienced, along with the stories I've talked to pilots, are remarkably low. And thankfully enough, with most of the systems, if they do have failures, they tend to fail on startup. I haven't had a whole lot in terms of failures in flight. So I would say categorically, yes, they're very reliable, and the ones that do have had issues, a lot of those, once again, all covered by the manufacturers. Most of the manufacturer support so far for each of these products has been quite impressive from my experience as well as that of customers.
Dave, are there any stats? I mean, clearly, there's been some reporting requirement changes related to glass systems and required reports if more than half of the system goes down, etc. Do we have any reliable stats at this point? I mean, there's clearly some concern out here, like I'm going to lose an entire screen and I'm going to lose all this data. What do we do? Do we hear of these events happening? Anything you can speak to related to that?
Sure. I don't have all the stats and the data, unfortunately. I don't have any of that in front of me. I know that the amount of information and the reason why they made some of those changes as far as information reporting so that they could collect that kind of reliability data, I haven't seen anything really popping out in terms of any kind of alarming issues. For those people concerned about a loss of a display or a loss in an individual unit, like I said, most of these systems have that kind of system redundancy built in, and I honestly have not heard you just don't hear the stories of panel failures and complete system failures. I haven't heard of any in the last 5 years. There were some originally when some of the panel systems came out, but these days you really just hear about how great and fantastic the systems continue to run.
Switching gears for just a second, you pointed out a lot of differences, distinctions, I guess, between some various systems. It seems like the takeaway from that would be that, hey, no two systems are built exactly alike. Would you characterize, I guess, that as true, and can you speak to the importance of specific training on the individual systems?
Oh, absolutely. We alluded to that very, very early in the presentation for just a line item, but that is absolutely correct. Each one of these systems is built by a singular manufacturer. There's no industry standard by which they're held to. So as such, each system does things differently. When you hop into an Aspen, and if you're comparing that to an Avidyne system, they're quite different as far as buttonology and symbology. In terms of display. So I cannot overstress enough the importance of finding a flight instructor who has experience in your type of panel system that you're considering or that you have purchased or are transitioning into, and then relying upon their expertise to get you across the threshold and barrier. And that especially applies for people who have flown other types of glass panel systems, because there is that false sense that, well, if I use the G1000, I can use an Aspen system. They are different.
Very good, Dave. I know we're just about out of time. Let me ask you for just a couple quick closing thoughts related to the individuals that are out there that are contemplating going to get some glass experience, or maybe they're contemplating upgrading their airplane to a glass system. What is step one? Where does someone start who's never experienced it before? Where do they start? What do they do first? And also, how do they go about finding either a flight school or a flight instructor that's going to work well for them in that scenario?
Well, sure. Well, two-part question. As far as if you're considering the upgrade or purchasing an aircraft with the system, obviously comparing and contrasting the systems that are on the market is a great place to start. You can do that on all their websites, sales brochures, etc. But you never underestimate the power of talking to somebody who currently flies that type of system. Getting a little on-the-ground experience is big help in terms of comparing the different types of systems. Beyond the sales brochure and that kind of stuff, go and take a test flight. Between, if it's a new OEM that has it, go and get a demonstration flight. Find a flight school that might be in your area, or maybe get a chance to do a cross-country trip somewhere whereby you can go do a familiarization flight in a G1000 system, for example, or an Aspen system. I definitely recommend that in terms of an opportunity to get it and try it. On the other side, if you're looking for resources out there, a lot of flight schools particularly tote themselves as having these type of systems available, and if they have them, the likelihood is that they have experienced instructors on their staff. There's always depending on your individual manufacturers, there's particular groups that will help you get in touch with flight instructors with your type of experience. Cirrus Owners and Pilots Association, for example, the Mooney Owners and Pilots Association, for example. A lot of these places are great resources in terms of experts, not only in your airframe type, but also in the glass panel systems. And then, of course, you can always do destination flying. Academies out there, like Sporty's Academy, for example, do a lot of accelerated 2 or 3 day transition immersion courses.
Dave, thanks a lot. Appreciate it. We're just a few minutes over. I want to thank everyone with us this evening for hanging with us. And also just a reminder that this webinar will be available, a full recording, both out on YouTube and at sportys.com/webinars. Be sure and check back with us often for upcoming programs. Again, on behalf of Sportys, thank you for being with us, and have a great night.